show that on the show. I think that's okay now. It's like a small video. Do it.
Good afternoon, ladies and gentlemen. Please sit rows, please. Forward. Please occupy the front seats. Let's make the auditorium compact, please. Ushers. My friends at the back seats, please move forward. We can also call to that's my own left of the auditorium, please. So that the camera work can be more beautiful. Thank you. Please rise for the Vice Chancellor's procession. The Vice Chancellor's procession coming in now, which will come to the podium. Directors of academic programs, directors of institutes, deans of faculties, the dean of students, provost college, medical sciences, provost college, postgraduate studies, the inaugural lecturer, and principal officers of the university, the Vice Chancellor's procession. While still standing, we shall take the first and second stanzas of the national anthem, followed by the UWAMUSI anthem. Cerebral and indefatigable Vice Chancellor, the distinguished Professor Robert Oyegi, ably represented by Kewan Campus, Vice Chancellor, Ekewan Campus, Professor Bunyamin Ayinde, Your Excellencies, top government functionaries, other principal officers of our great university, the provosts, deans, directors, the inaugural lecturer and family, professors emeriti, other esteemed scholars here present, my Lord, spiritual, greatest university staff and students, invited guests, gentlemen of the press, distinguished ladies and gentlemen, good afternoon. We welcome you heartily to this 334th inaugural lecture of the University of Benin. The lecture is to be delivered by an affable and erudite scholar, a gentleman per excellence, a professor of industrial mathematics, Professor Stephen EHIDIAMHEN. The topic of today's lecture is Error Approximation Catastrophe. Can interval analysis be the panacea? May I now invite the representative of the registrar, Mrs. Comfort Ehidiato, Deputy Registrar Senate Matters, to introduce the Vice Chancellor and the Vice Chancellor's procession. Acting Reg.
Vice Chancellor, sir. I welcome you all to the 334th inaugural lecture in the series of this great university. The Registrar of the University, Mr. Ademola Bobola, is engaged in official assignments, and he has requested me to stand in for him. He sends his greetings to you all. I am Comfort Deputy Registrar, Senate Matters. Permit me to stand on the already established protocol as established by the Public Relations Officer, the PRO of this university, and to introduce the Vice Chancellor's procession. Today's procession is led by our determined and focused Vice Chancellor. I therefore crave the indulgence to present to this great audience our own very learned civic, the Vice Chancellor, Professor Doba Omori, who is represented here by DVC Ekewan Campus, Professor Ayinde. All principal officers, provosts, deans, and directors in this procession are as follows. Professor D.N. Izeko, Provost, College of Postgraduate Studies. The Dean of Students is represented here by Dr. E.E. The Host Dean, Physical Sciences, Professor E.O. Ayomi. The Dean, Faculty of Agriculture, is represented by Professor J.N. Omayaki. The Dean, School of Basic Clinical Sciences, is represented by Professor Mrs. Caroline Omoti. The Dean, School of Basic Medical Sciences, represented by Professor A.P. Usadolo. The Dean, School of Dentistry, is represented by Professor Mrs. I.N. Izeya. The Dean, Faculty of Education, Professor K.O. Amorudula. The Dean, Faculty of Engineering, Professor E.A. Ogunjo. The Dean of Faculty of Law is represented by Dr. Mrs. Irene. The Dean, Faculty of Life Sciences, Professor T.O.T. Mobe. The Dean, School of Medicine, Professor N.O. in Aruna. The Dean, Faculty of Pharmacy, Professor Igodaro Ibe. The Dean, Faculty of Social Sciences, Professor Morbius Ube. The Dean, Faculty of Vocational and Technical Education, Professor EHIDIAMHEN. Director, Center for Part-Time Programs, Professor F.E.U. Director, Center for Distance Learning Program, which represented here by Dr. Darlington Ubege. Director, Center for Educational Technology, Professor EHIDIAMHEN. Director, Center for Sustainable Development Goals, Professor Mrs. Udu. Director, Quality Assurance, Professor Peter Isede. Director of Advancement and Development and Human Relations, Professor Eddie Iraili. Director, Advanced Digital Engineering Center, ADEC, Professor Mrs. P.E. Orube. Director, Institute of Child Health, Professor Mrs. Ayebo Sado. Acting Director, Institute of Public Admin and Health Services Management, Dr. John Usada. And I have the honor and privilege to invite our dear Vice Chancellor, represented here by Professor Andy, to introduce the inaugural lecturer for today. Vice Chancellor, sir.
Great Uniben, Principal Officers of the University, Provost College of Medical Sciences, Provost College of Postgraduate Studies, Deans, faculties and schools, Directors of institutes, members of council, emerita professors and members of Senate, retired and serving professors of this university, my Lord, spiritual and temporal staff and students, distinguished invited guests and friends of the university, gentlemen of the press, distinguished ladies and gentlemen. I bring to you live tidings, words of congratulations to our lecturer today from our dear Vice Chancellor, Professor Eduba Omarike, who would have loved to be here, but due to some very pressing issues, very important meetings going on. In fact, he wanted to be here. It was just the time that he just asked us to quickly find our way here in order to honor our lecturer for today. It wasn't intended. So, apologies, please. I'm reading his speech. It is my pleasure to welcome you all to the 334th Inaugural Lecture Series of the University of Benin. Today's lecture is the 8th in the Department of Mathematics, the 23rd in the Faculty of Physical Sciences, and the 5th to be delivered in my tenure as the Vice Chancellor of this great university. Ladies and gentlemen, it is my delight to introduce our lecturer for today. He is Professor Stephen EHIDIAMHEN, UWAMUSI. The title of this lecture is Error Approximation Catastrophe. Can interval analysis be the panacea? Professor Stephen EHIDIAMHEN UWAMUSI was born on 26 December 1965 to the family of late Chief James UWAMUSI Otobo and Mrs. Agnes UWAMUSI Otobo of Essen South Local Government Area, Edo State. He obtained the first student certificate in 1978 from Idumu Yasile Primary School, Ewato. He attended Ewato Grammar School, Ewato from 1978 to 1983, where he obtained his West African School certificate. Professor UWAMUSI gained admission into Bende State University, now Ambrose Ali University, Ekuma, in 1983, to study industrial mathematics, and he graduated with a Bachelor of Science honors degree, second class upper division in 1987. Professor UWAMUSI undertook the one-year mandatory national youth service at Government Secondary School, Namu, Old Shendan Local Government Area, Plateau State, between 1987 and 1988. To broaden his knowledge, he obtained the following additional degrees from the University of Benin: Masters of Science degree in Industrial Mathematics in 1991 and PhD in Mathematics 1998. Professor UWAMUSI in 1991 was interviewed and found appointment at the then Faculty of Science, University of Benin. It was while awaiting the letter of appointment, he was offered employment as an assistant lecturer in 1992 by the then Penn State University, now Panacea University. He joined the services of University of Benin in 1993 as an assistant lecturer in the Department of Mathematics, and rose through the ranks to the position of professor in 2012. Professor UWAMUSI has held several administrative positions within and outside the university. Some of them include Industrial Technical Coordinator 1999 to 2009, Faculty of Sciences Representative to School of Basic Medical Sciences 2014 to 2017. Head of Department of Mathematics Science, Kogi State University, 2014 to 2017. Professor UWAMUSI is a member of professional bodies, associations, and affiliations, some of which include Associate Fellow, Good Educational Quality Leadership, Institute of Industrial Administration of Nigeria, member World Class of Mathematics of Professors, Associate Editor, Research Journals of Mathematics and Statistics, Maxwell Scientific Organization, Pakistan. Professor UWAMUSI has over 63 publications in local, national, and international journals, and has single-handedly authored the text and the chapter in the departmental book series. Thank you. He has supervised some postgraduate students. He has served as external examiner to some Nigerian universities and has been a member of accreditation team of Nigerian University Commission to federal, state, and private universities. Professor UWAMUSI has attended many conferences, seminars, and workshops within and outside the country. Professor UWAMUSI hobbies include footballing, reading, writing, and counseling his students. He is married to Dr. Mrs. Cordelia UWAMUSI, Lecturer 2 in the Institute of Public Administration and Health Services Management, University of Benin, and the union is blessed with 4 wonderful children. On behalf of our dear Vice Chancellor, Professor EHIDIAMHEN, I hereby invite Professor UWAMUSI to deliver his inaugural lecture.
Mr. Vice Chancellor, sir, Deputy Vice Chancellor, the Registrar, other Principal Officer, stand on the existing protocol. His Inaugural Lecture Series 334 for the event, titled Error Approximation Catastrophe. Can interval analysis be the panacea? In this, we are going to talk about sources of errors, how to ban errors, this from. Okay. Then, why the ordinary law method analysis did not meet up to the expectations in the field of computing, and why interval analysis is introduced as a panacea. Thank you very much. Let me go straight to the point. I would like to dedicate this inaugural lecture series 334 to Almighty God, who has been my protector since I was born. I also wish to thank my late father, Chief James UWAMUSI, for single-handedly sponsoring education from primary to university level, even though he lost his parents at the age of 10. We know what to take him to school then, even primary school. But he grew up very strong, among the strongest among his peers. Though he died on the 17th July 2018 at the age of 93, his death is still having effect on me. I'm still here to recover from it. I also want to thank my late mother, Mrs. Agnes UWAMUSI, the Wooliman. Motherly advice to me, which shaped my life at a later stage in life. At the age of 86 years, on the 9th of September 2023, I should also like to thank my and support she led while I was growing up. I also go to Thanks also go to my PhD supervisor, Professor Francis Ogona Otunta, who supervised my PhD at a critical stage in history. I must not forget to applaud my amiable wife, Dr. Mrs. Cordelia Beauty UWAMUSI, for her support and love to me as a wife. I'm also grateful to my children, to whom I derive joy. Mr. UWAMUSI Marvelous Otobore, Barrister Emmanuel Ahuse UWAMUSI, Barrister Jessica Ame UWAMUSI, and Mrs. Mighty UWAMUSI. Preamble. It is a great sense of humility that I stand before this audience today to deliver this great inaugural lecture at the University of Benin. The first question every numerical analyst, as well as engineer, scientists, usually at inert relation is, what is the error in the computer? Errors come from various. According to SOA and TAT, there are three main sources of errors. Error, put data, random error, and approximation error. The first error in calculation emanates of the instrument used. Error arise in the calculation approximation error. When you try to approximate a given function by another function for easy solution, the error committed is from the given. For example, we want to illustrate this by considering function 1 plus t bracket 1 plus t equals to 1 minus x s squared and so on. So from 0 to x, if by replacing that with the equation 1, if you replace the other one, equation 1 by minus x, you have log 1 minus x equal to minus x over 2 minus u over 3 and so on. Simply considering y as a function, we obtain equation 4, which as log y is equal to minus 2 summation k goes from 0 to infinity 1 over 2k plus minus y over k plus 1. This is when the absolute value of 1 minus x over 1 plus x is less than. And we are going to illustrate what this means. For example, considering the application of this matrix function in the motion of Euclidean norm, we have log equal to this, and log a is equal to summation equal to this. And if we consider the equation we did, and we have a equal to minus 2 summation 1 over 2k plus 1 into 1 minus a into 1 plus a raised to power 2k. All these converge to make the absolute value of a is less than. The basics of this is that series are subject to for the original function we get to into the concept of floating point arithmetic, the sources of error. As we know, the roots of electrical electronics engineer usually set a standard within the operation of IEE format that develops global standard in broad range of industry, including power and energy. For example, IEE 754 is being used in personal computers and workstations. And the purpose of this is to specify basic and extended for floating point number elementary operation and random conversion between different numbers. Binary decimal conversion. There's also a rule for handling exceptional cases like exponent overflow and underflow. So, according to Job 2009, a single precision arithmetic can be computed as stated. Because of time, we move forward. And in this case, what we have to a component of error has to do with single precision arithmetic. For example, overflow error, the largest the smallest computer can accept in a single precision is 2 raised to power minus 22. And what the largest it can accept for double precision is 2 raised to power 10 raised to 2 times 10, 2 raised to power 10 to 3 as stated. So point x and y, we consider the floating point in the form but x float bracket y float all the floating point addition, floating point subtraction, floating point, and floating point division. For example, float point x equal to x operating y into float 1 plus delta. Delta is mu. The highest number the machine can accept. So as seen from the above, as seen configuration, you see that measurements are so it is necessary to measurement of experimental problem in the form of process. Right? We are not too sure. In the next we are taking. Oftentimes, most works we do in medical analysis involve quantities. But those medical analysts are interested in mapping that are accelerated by method that converge very fast and strongly accelerated in the sense that the sequence of height rate converges very fast as soon as possible. Unfortunately, these convergent methods measure this point instead of introducing pessimism in the certification of these results. Most vital information will then be lost regarding automatic rounding off error and propagating. This lecture aims at addressing this problem using interval, the wise word, G-interval arithmetic. The interval arithmetic is called matching interval arithmetic. And basic tools we use are the Banner fixed point, Brewer fixed point theorem, Minada fixed point, Shada fixed point theorem, and as corroborated by Catastrophy theorem for the classes of continuous function. And we report all this in this regard we use sources. The interval arithmetic. Aaron Imo was the first to consider interval arithmetic as a way of Grant was an employee in Lockheed Missiles and Space Incorporated. He was working in the lab where they manufacture bombs and all that. Lockheed Missiles is a major laboratory in the US. Interval arithmetic was officially introduced into computing in his speech by Moore in 1966. And since then, many researchers have come into it a way of diminishing and capturing all round-off error automatically aided by the use of computer. Although computer play a very good role in scientific computing, many instances computer also is not equipped. The thing that computes when mathematician or a scientist, engineer, even economist perform calculation when floating point arithmetic are used and floating point arithmetic number are used by matching number. Two types of error emanate. The first, when a value data is appropriated by matching, while the second error arises intermediate result being approximated by the matching number. So this concentration, when performed, will be affected by rounding errors. As errors committed at once will drastically affect every other source and thereby rendering the conclusion of the result. Yes. So difficulty. The researcher had always faced with the multiplication, interval arithmetic was introduced to automatically these errors and also able to estimate and control these errors in the computer. Mr. Vice Chancellor, sir, many people have always thought or had wrong impression that interval arithmetic was all about elementary arithmetic taught in primary schools or secondary schools. This is not correct. As you will know later, interval arithmetic is an advanced form of numerical analysis. Is higher than numerical analysis in computing, in the sense that it does twice the job a numerical analyst does with already known methods. It's a two-sided approximation. Like when you are going to a new Lagos road, you see double lane. But when you enter inside town, you will see one lane. Interval arithmetic is a double lane. So, because of time, interval arithmetic, as you know, has a rich set of numbers, operations associated with it. Let us see how we represent an interval. An interval is, you take a number x and call it interval x, which is equal to lower bound, we represent it as x under, x bar. That is x under represent the lower one and the x bar represent the upper one. And to if you now take the midpoint of lower and upper, you have mid x is equal to half into x bar plus x value and plus x bar 1. That is the upper and lower. Then the radius, when you subtract the x bar minus the lower bar and divide by 2, you have the radius. In other words, you now have x is equal to x bar minus x bar plus r. That is the basis of understanding it. For example, for AB in the interval AR, interval arithmetic is represented as I of R. The quantity D into AB, as given by expression maximum, absolute value of A, B, and upper B, subset of R, is a metric Hausdorff distance. It's a distance. A distance can be from here to here. It can be from here to Lagos. It can be from here to US. It can be from here to anywhere. So that you understand what I'm talking about. So that if we now consider the expression x equal to interval x lower and x bar, the lower bar is called infimum. The smaller the lower bar is called the infimum, while the upper one is called the supremum. So when x bar equal to the lower bar is equal to upper bar, it degenerates to a number we usually work with in mathematics, engineering, economics, science, biology, anywhere. So that is what we need. For example, to show that interval x belongs to this, it has to show that the lower band is contained in the upper band if and only if the absolute value of x bar minus lower bar is less than radius, and that was done in UWAMUSI 2007, and we will see what that one means later. So as we have seen, like any other numerical, the interval has a rich set of arithmetic associated with it, including binary operator for the basic operation, addition and multiplication. So the properties are defined as follows. You have addition, you have subtraction, you have multiplication, and you have division. And it will interest you to know that the way you do subtraction in interval arithmetic is not the same way we do it in other mathematics. For example, interval minus 2, is, if you subtract it from itself, it's not 0. But whereas 2 minus 2 in ordinary calculation is what? 0. That is what we will understand. And is the trick we need. So we also have a dual as part of interval arithmetic. It's another branch of arithmetic. Dual is a monadic operator that reverses endpoint of interval, mapping elements to elements between improper and proper intervals. For example, the dual of A is equal to, when you reverse the endpoint of A, is that the dual of A is A, and the dual of bracket A operation of B is equal to the respective dual of A multiplying the dual of B. And A minus the dual of A minus dual of A is 0. But in ordinary arithmetic, interval A minus interval A is not 0 unless A is a degenerate number, unless A is 0. So the containment set for interval is given. We will also have a containment set for this. Why am I explaining this? If you don't understand all this, you cannot work with interval arithmetic. So this is the way to do the division in the interval arithmetic operations and this. So there are 3 main types of interval arithmetic. You have the ordinary real, you have the ordinary real complex, you have the rectangular, and you have the circular arithmetic. The circular interval arithmetic was introduced by Gagatini and Herisi in 1972 as a way of simultaneously finding approximation to zeros of polynomial in the form of circular region DC. And what's a DC? According to Gagatini and Herisi, 1972, is an extension of a number in the extended complex way, whose projection is bounded by a circle, whether it is a boundary or its exterior point. The important thing is that it remains within that region. So the next thing now is why interval arithmetic? Why is interval arithmetic now the solution to the problem we eliminated? Because of floating points, propagation error, input data error, and so on. Interval arithmetic is an elegant tool for practical work with inequalities, approximate numbers, error band, and more generally with certain convex and bounded set. Interval arithmetic connotes a sharper representation as specified by the tightest representable lower and upper bound of a number, like in an interval. That was according to Nehemiah in 1999. And he now gave exactly 9 possible areas where interval arithmetic is widely used worldwide to represent representation of number, physical constant, conversion error, and so on. So interval arithmetic is so sensitive to the manner in which we operate on it. For example, if you try to falsify results while computing with interval arithmetic, the result, the method will break down. What do we do there? And for this battery to work, it was programmed that the battery should count tenths of a second before converting it to seconds. It has to multiply by 1/10. And mathematically, you see that that is unreasonable, but procedurally is unassailable. Computationally, it was disastrous, as you will see later. Apparently, the conversion constant stored in the program was 24-bit fraction, like this. This was how it was stored to protect any score missile that was to be fired to quickly rise up and intercept it. But because of Randolph error, the computer accumulated Randolph error. Instead of intercepting it, about just 1/10 of a second, the computer malfunctioned. The battery malfunctioned with 700 meters. And the soldiers that were stationed on ground to protect all this oil installation were killed by the enemy's Scud missile. That was when Saudi Arabia insulted the U.S. And U.S. had to destroy Saudi Arabia's oil installation in 1991. Another area where that happened was the death of EHIDIAMHEN 5 caused by an overflow of error when the satellite invented its engine and slided up the coast of French Guinea. A satellite that was stationed in space to be spying on other nations. Because of wrongly programmed interval methods, the engine ignited itself and caught fire and 5 people died. Also, not too far away, in December 27th, 2019, the American broker at Iraq that sheltered several thousand of the United States Army stationed to fight and subdue ISIL was hit severally by the Scud missile fired by the Iranian army. Although it was initially denied that no American soldier was hurt in the blast, some days later, the American chief of defense came out to report that more than 100 U.S. soldiers were having ear, hearing, and brain stability problems. The U.S. defense mechanism thought to be impenetrable failed to respond quickly to the external Iranian Scud missile fired from the Iranian soil into Iraqi territory. Actually, I was in mid-70 year. I was the first person to sell the idea of interval arithmetic to Iranian authority. That was 1999. And it has to do with the paper I published there. When I sent the papers to their nuclear research center, they wrote to me to ask what was it used for. I told them it could be used for manufacturing bombs and others. They now told me, okay, thank you. Since then, Iranians and Pakistanis have gone far into the use of interval arithmetic. Mr. Vice Chancellor, sir, and other distinguished guests here present, I wish to let you know that an interval analyst does the job of a pure mathematician, applied mathematician, and engineer. All this being manifested in his quest to formulate a program providing their solution with guarantee automatic error pass much as possible. Interval arithmetic widely applicable in structural engineering, mechanical engineering, and vastly mostly demonstrated in electrical engineering practices. For example, in UWAMUSI 2021, it was stated that it has usefulness in computer graphics and visualization and ray tracing implicit surface. That is University of Lagos Journal of Mathematics. It is also widely used in medicine. Impact of studies. Mr. Vice Chancellor, sir, it interests you to know that I have made great significant impact and contribution to the growth and development of interval arithmetic computational analysis, and also the computational methods in numerical analysis in general. This not by word of mouth or exaggeration. I as you will see later. I have worked in the area of theory of polynomial zero, non-linear system of equation, linear system of equation, interval least square method, matrix value problem, and so on and so forth. And why doing this? Banner fixed points, banner spacing, barrel spacing, and hyper spacing were of paramount importance we were working through in expressing very difficult mathematical expression. I have also worked in the areas of applied mathematics such as the flow of ocean water waves relating the effect of Reynolds number and varying pressure to the ocean water waves. UWAMUSI 2019-20. The wave amplitude modulation for the progressive wave which move with group energy and the work number the wave plane were detailed. Because of space of time. In another development, apart from working in the floating point method, and now extended into multivariate function extension to the use of interval arithmetic, linear interval system of equation were later studied. More recently, progress has been made to include the linear interval least square with respect to removal from water noise in the linear model. For example, in a paper by UWAMUSI 2007, the procedure for decreasing excess width of interval multiplication was introduced into the field of computing. Using Catastrophy and 1994 circular interval arithmetic, I was able to modify this method that converges so fast with removing that has capability of removing noise, data noise from computing. And this paper was accepted and was reported at the Institute of Reliable Computing, Hamburg University of Technology, Hamburg, headed by Director Professor S.N. Ron, and listed in interval lab among the best 200 publications, including masters and PhD theses that were selected all around the world. One thing about this paper, the first I published this paper, it was a professor of pharmaceutics in pharmacy that first made use of it as his reference, a Chinese. Before I knew it, in less than 6 months, the thing now got into the hands of the Germans and later spread to the US, which was also reported and listed and advertised at the website of Penn State University. So in another paper, 2009, I also published another article which I modified, and it was also accepted and listed in the interlab by Professor S.N. And it's listed and being advertised in Google Scholar page, Microsoft search for authors, and the website is this. So in another development in 2008, there was a need, and I considered the first 2 papers I published, and I said there was need to enlarge the disk. What happens if the disk is enlarged? And I did computation, modified it, and I saw that if the disk is too large, that implies non-linearity, large non-linearities in the system, and that will drastically affect all methods based on center form. And this paper was selected by Z Academy of Sciences, Institute of Computer Science, University of Jas University, Pro, and it's in their website. And it was listed, selected by the former head of the director. That one personally advertised it in his personal homepage, Professor G. He has retired now. So, Vice Chancellor, sir, conclusion. Vice Chancellor, sir, I wish to state that my research in the past years have been concentrated on interval computation analysis for polynomial or single variable and non-linear system of equation called interval arithmetic. It is a part of modern-day approximation analysis which deal with self-validating numerics automatically take care of error bands. It came to pass that there was a need by the World Ranking Body that mandated the University of Hamburg to reassess the past already published article headed by Professor Ram. When everybody began to say his institution is the strongest and all that, the work body decided to mandate Professor S.N.O. and his institute to actually verify which are the papers that are really strong that met all these conditions. About 300, in 2007, about 3,000 publications that were already in circulation published from 1993 to 2007 were collected all around the world. Whether the paper was published in Science Journals, Springer's, Technica, Agronomy, they screened all of them. Only 200 publications were successful and mine was counted as one, listed as 179. Also, in the year 2009, as I told you, a repetition was made. This time around, they collected 4,500 publications, including PhD, master's thesis, when people now began to complain why they are not monitor. Then they collected 4,500 publications, and they used machine to search and verify. Only 290 publications met the requirements, the standard, and my second paper was counted and listed there. So, like that. So, in the nation, interval arithmetic plays major role in sciences and engineering in the globalized world. Its influence has been better appreciated in computation and experimental design. These are areas where interval arithmetic are recommended. Interval arithmetic is a powerful tool to counting errors in experimental design. Interval arithmetic is self-validating, wherein we guarantee error bands, equipped with ubiquitous verification resistance and uniqueness. The use of interval arithmetic has not only effectively been utilized in the experimental program, but also has been widely acclaimed as automatically able to fence in all numbers of errors. When you are not too sure, and interval arithmetic is different from what do you call it? The one we do in statistics, in statistical inference. The two of them are not the same at all. They don't even get. Only stochastic arithmetic that has a little resemblance to interval arithmetic. Acknowledgements. I wish to thank our able Vice Chancellor, Sir, Professor E.B. Omoreke San and his management team for honor given to me to deliver the 334th Inaugural Lecture of this great university. I should also extend my most sincere thanks to former Vice Chancellor, Professor A. Notorayi, who allowed my promotion, my employment to schedule when he gave me as a substantive Vice Chancellor of the University of Benin. And also to former Vice Chancellor, Professor F.O. Orumesi, under whom my promotion to professor was announced. To these people, I'm most grateful. I should like to thank the following people who shaped my life in academic work. Mr. S.A. Bakari, my secondary school principal, Ewato Grammar School, who took interest in monitoring my study as a student, then at the grammar school. He got to know me after our first term exam, the way I performed. He personally came to the class to ask of me. And there was a day I missed coming to pray. He now saw me as somebody who did not want to be coming to pray. We were flogged. Since then, I noticed that the following day, he saw me, he was always addressing me a professor. I was still in class 1 at secondary school. I also want to thank Mr. Dr. S. Okoje, a retired staff and former deputy registrar at the University of Benin City. He was the one that assisted me then to gain admission to EPOMA when we did not I originally wanted to read pharmacy and engineering, but they did not take us. He was the one that assisted me. So, I also want to thank Professor U.S. Asikiroka, who taught me numerical analysis, and my project supervisor at undergraduate. I want to thank Professor S. UWAMUSI supervised my MSc Mathematics when I came here for my master's. I wish to thank Professor S. EHIDIAMHEN, who first discovered my talent while I was still in the master class. To him then, after our first semester results were released, he saw the way I passed out of the roadblocks. Other people failed, and I passed. He said for me, I began to ask me questions. So when I wanted to actually travel, he said no, he told me that he was not going to make the mistake of releasing me into the wrong hands. I didn't want to put wrong hands here. He said he did not want to release me into the wrong hands of other universities, that he was going to retain me. That was how I was eventually retained at the end. I wish to thank other people here present, Professor, my thanks also go to Professor F.E. Okeme, former dean, and the one-time deputy vice chancellor academics. My thanks also go to Professor Tuta. I'm sure he would have been here at this University of Benin, where he known for his timely death in 2021. May God rest his soul. I wish to thank Professor Ijoji and other people present. Okay. It's okay, thank you. Because of time, I will not be able to mention the names of other people present. My thanks go to those invited guests who came from far and wide to attend this inaugural lecture. Thank you so much.
Thank you, sir. No, he did at the beginning, but you should again. I appreciate Madam again, sir.
I've been permitted to use extra time. I wish to thank my wife for her steady love, caring love, my children for whom I derive joy. Thank you very much.
Thank you, sir. Please clap, 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 clap. It is not for nothing that we call it almighty mathematics. In January, Professor Lucy Erekwame told us that we may not want it for obvious reasons. Today, I got even more confused. So please clap for the lecturer. May I now respectfully invite the representative of the Vice Chancellor to recap the lecture. Thank you, sir.
Thank you, Madam P.R. Well, you are not the only one confused. I know the only ones that are not confused are the people that are from mathematics family. All of us, we are confused. I remember when we were in secondary school, Form 1 that time. You know, those of us that entered secondary school from primary school, we were used to simple mathematics. First time when our teacher there, Mr. Sanusi, now started teaching us mathematics, he wrote minus 3 plus 2. We started wondering, minus 3 plus 2. It's supposed to be 3 minus 2. Those of us that were seeing that for the first time, we wrote 1, 1, 1. And he started explaining. We started wondering, how will it be minus 3 plus 2? I didn't know we started the confusion that time. Today's school has compounded it. Our lecturer, Professor UWAMUSI, has given us a detailed progress about his work on interval and arithmetic. He has shown us that interval arithmetic is an elegant tool for practical work with inequalities, approximate numbers, error bands, and more. The methodologies of approach make use of functional analysis, topological spaces, complex analysis, matrix theory, polynomial zeros, and machine numbers in computing the solutions and convergence of problems formulated in the forms of linear and non-linear systems of equations. It was demonstrated that interval arithmetic connotes a sharper representation as specified by the tightest representable lower and upper bounds of a number lying in an uncertain interval. It followed that interval arithmetic has capability of removing uncertainties associated with data errors from the given problem, which guarantees error bands to the range of a given function. It was shown that many Patriot missile batteries do fail due to accumulation of random errors and an overflow of error due to lack of designs using interval arithmetic operands in their formulations. The lecture also reported works of great significance on the treatment of ocean water waves, their group velocity, where topological space and complex analysis in applied mathematics are a useful tool. You agree with me that our university, the great University of Benin, is made of seasoned professors who are not just professors of national importance, they are also professors of international value. You agree with me? On behalf of Vice Chancellor Professor UWAMUSI SAM, I congratulate the family of our lecturer and also himself, particularly the wife, because we do say when we have the man as the head, it's the neck that carries the head. If the neck doesn't stand well, the end will be nowhere. Madam, thank you very much. In the light of that, I want to thank every one of us on behalf of our dear Vice Chancellor for your patience, for your time. God bless you all.
Thank you very much, sir. The Vice Chancellor's representative will now decorate the lecturer as we invite the immediate family members, Madam and the children, if there are brothers and sisters, direct family members, please join. We welcome heartily the spouse, Dr. and Mrs. Cordelia UWAMUSI. Please put your hands together. The children, Marvelous UWAMUSI, Emmanuel UWAMUSI Esquire, Jessica UWAMUSI Esquire, Dr. Miss Mighty UWAMUSI. We welcome you all. Please put your hands together for them. We welcome very specially Olori Iyason of Ondo State, Elizabeth Akinyomi. Please put your hands together. Please join them for photographs, please. We will welcome Professor Emeritus Musa Elafona. Welcome, sir. Welcome Professor Emeritus Raymond Olano. Welcome the former DVC at Kawan Campus, Professor Joel Abolaga. Professor Charles Umarin Biaye, we welcome you. We welcome Professor Esohe Omoregbe. We welcome the Director of Academic Planning, Professor Joseph Ogrebiaki. Osenekai, I beg your pardon. Professor Joseph Osenekai. Welcome Professor Francisca Ebogari, MNR. Welcome Professor Julian Bebe. Welcome Professor Venerable Sunday Omosiro. Professor Felix Osaga, we welcome you. Welcome Professor Charles Mukeki. Welcome Professor Medina Kadiri. Welcome Professor Emmanuel Ogre. Welcome Professor Lucy Uregweme. Welcome Professor Felix Aigwabian. Welcome Professor Ehidiato Abayonsi. Professor Solomon Omosigo, we welcome you, sir. Professor Solomon Omonigo, we welcome you, sir. Welcome Professor Henry Akinibosu. Pastor Paul Olawari, we welcome you of the Redeemed Christian Church of God. Welcome Barrister Victoria Obunu. Again, we thank you all for coming as we conclude the 334th Inaugural Lecture of the University of Benin. We shall now rise for the then the third stanza of the national anthem. Please stop serving at the anthems. Please. To leave the arena, and you may continue to serve refreshment. Please.